Right, well, let's have a look at a set that I bought in a batch from Lancashire a couple of years back. This is clearly incomplete because it doesn't have an arrow socket. It's a Signal 1001, which is JWR M2 or ICOM, whatever it was. Nothing to do with the real company ICOM, just a made up name. I'm not sure what we're going to find. This may be a very quick video putting it back together again as spare parts, but I'll tell you what, the trouble with these is they were quite easy to put on 28 megs, and so a lot of them got, I think the phrase is, farted about with. But this doesn't look bad. I remember these being cleared at £19.99. Yeah. I think we're going to find a scrap chassis, so we've got exactly the right connector it's supposed to be. Because a lot of scrap chassis, because as I said, a lot of them got messed about with and got wrecked. So I will look amongst my souvenirs, let's queue for a record and see what I can find. Right, well, in view of not knowing quite where the information is, we'll move over to that JWR set and see if there's something we can do with that. And come back to this another day. Obviously that's going to have to be dealt with at some time. Now the sockets on these, you saw the socket on the back of the one's a Uniden type socket, and they're the same socket which were on the AM Midland Precision Series 2001, 3001, 4001. So we're bound to be able to find a scrap one of those, which means we can recover one of those sockets, and therefore it's not going to cost us anything, which is always good. The fact it's got a red number is it's one that Mark's tested when he's been here and announced to me that it doesn't work. So I'll power it up and we'll see what doesn't work on it. It's lit up, it was on 19. Looks like it's receiving the signal generator. I saw the meter move. Plug the mic in. We have transmit. Somewhere like on frequency. So let's plug the speaker in. Okay, so we've actually got receive. Well, that's nice, isn't it? But it must have not worked properly for Mark, so a quick test with just to the walkie-talkie. Testing 1 2. Testing 1 2. So on the face of it, it does work. So I wonder what Mark discovered wasn't right. Well, the first thing we have to do is set the 10.24. This is the pain with these sets. You've got 10.24 to set, you've got transmit to set, you've got receive to set all separately. Did I switch it on? No. But they've always got good transmitted audio, as long as they're not humming. MC145106, I can't remember which pins the crystal are on. I wouldn't be surprised if it's across those test pins, and we're not going to do any harm if we put the oscilloscope across those test pins. Let's press auto set and see what we get. Well, 5.13 is not what we're looking for. Let's find an earth point. It's not that one. That might be a VCO test point that we don't know about. Right, well, if we find the DNT information, it's the same synthesizer. So it's MC145106, MC145106. So the reference crystal is across pin 3 and 4. So pin 3 and 4. Let's get ourselves to pin 3. Or 4. 10.2379, so it's slightly low. So we can get that up a bit. Let's just hook onto there. Get the trimmer. I'm sure I've covered these in great detail. I usually throw away the notes because I think, well, I'm never going to see one of these again. Nobody's going to have one of these, are they? The idea was to cover one set once, you know, that was it. So that when I've croaked it, people know how these are done. So see if we can get it a bit higher. Let's just see whether we can get transmit. For some reason the other cameras are off. I don't know what happens when I turn my back. Let's go to the other switcher. Okay. What we're going to do, I don't know which one's transmit and which is receive. We're going to find out, aren't we? So let's go for the right hand one. So you can see we're 10.793 something, it's too high. So that, can we bring it down to 79125? Okay, so we're on frequency on transmit. So let's see if we can get it on frequency on receive. If we can, we're on to a winner. So with the secondary signal generator, just make sure that our main signal generator is spot on frequency. 27.79125. Just trim that to be spot on. Like, come on, exactly like that. Okay, and now we'll switch this signal generator on. Turn the tone off on the signal generator. Must be spot on. We're looking for that null. We're exactly spot on. So we've got 10.695 on the secondary signal generator. We know we've got 27.79125 on the main signal generator. So we know we've got transmit right. We know we've got receive right. We're on frequency. Right, tone on. Good sensitivity, 1 microvolt. I'll go and get a sheet of paper and we'll start writing these things down. Right, let's go through this then. So, go to the main meter and see see what the transmit power is. We're on the 3 watt scale. It's doing 3 watts. Let's go to a different channel. Put the squelch on. The squelch is weak on these sets. 1.8 watts. Other way round, 1.8 watts. The channel 1, 3 watts. Low power, back to channel 20. Oh, that was low power. Okay. So same on both. Transmit current 875 milliamps. Deviation for what it's worth on this test set. Wallow 1.8. Frequency, we can't tell what it was before, but it's 2779125. When we press transmit, the meter says bangs across. So we've put down FSD for full scale deflection. Signal generator on, 100 microvolts on the signal generator. What does the meter say? And it says just about S9. So for S9 it is 210 microvolts. It's not that far out, what you'd call a lazy meter, slightly, but at least it's adjustable. Meter lamp works, switches work, potentiometers work. We've got noise on volume control. Vol control dirty. Sockets work, it doesn't have PA. That's a good start. Let's have a look what the receivers are doing. So put the sine nav meter on, we'll have to plug into the test equipment speaker instead of the speaker on the wall. Test equipment speaker set. See. Turn the squelch down. And at the moment we've got pretty good sensitivity. 0.72 microvolts. Naught 0.6 for 20. If it does it does. It's 3. Squelch. It's 1.1 microvolts. In full. It's 1.5 microvolts. Right, let's see whether we can do anything with it. Start on transmit. I'll have to print off a circuit diagram to see which ones down here we're doing. I don't want to upset the VCO. Some of these have got wax in. Some of them it could be unnecessarily. Like, I mean, that's the detector, isn't it? Why would anyone put wax in that? But unless you're driving a tractor, I suppose. Anyway, we'll go through these, make a start. So, make sure we're on that meter. We're on full power, and it's 1, 2. I don't know whether we're in there or not. So, let's put the soldering iron on. I think we've got a dry joint as well somewhere. I'm not getting anywhere because the soldering iron is going to have... I don't like people putting wax in polythene coils. It's so easy to melt. I could use earwax removing stuff, but I don't have any. doesn't feel right. Lower, about 3.6 at the moment. We'll come back to this, but there is a dry joint somewhere. I'm not sure where we are with these three. And the fact it was doing lower power on channel 1, it's not doing now. Oh, it's channel 40, it's not, it's 1.5 watts. So I think something's out in the lower stages here, so I will just have to look at the circuit diagram. Right, so let's see whether we can get somewhere with the receiver. Let's put about that on. So, oh, I'll tell you what, we'll do 100 microvolts. We'll set the detector, and we'll do that with the oscilloscope. So that's all that's going to be the detector. Mr. Wax has been busy. Just do the IF. Let's go to the synod meter. Unfortunately, that was in the wrong position, which when you wax them, doesn't help, does it? Put a lower signal on. That was right. I don't know what that is. So I have to do the look at the circuit. But we've now got 0.56, 0.56 microvolts. So definitely improve that. And of course it's on frequency now. Let's see whether we can set the S meter up. There we go, that's now S9, 400 microvolts. Just see if we can find which one's transmit meter. Could be that one. It is, centre of the red zone. It's a transmit meter, receive meter, low power. It is that one. 400 milliwatts. don't think you get a squelch one on these. You get what you're given as far as squelch goes, and deviation must be somewhere. It's going to be there. It's going to be there, isn't it? So let's look at that with the other test set. I'll plug into the test set behind me and see if we can get a deviation figure. We were getting 1.8 on this Marconi test set. It sometimes lies. So we'll go to here. Wow, it's absolutely spot on. It's peaking at 2.5. That's the end of that query. So at the moment we're doing about 3.7 watts, but it's not quite right because it's considerably different from channel 40 to what it is to channel 1. So somewhere in this earlier stage, I'm going to print off a circuit diagram and we'll work out what's what. Right, I've dug out more information. Basically these are similar circuits. This was to convert these to 10 meters, which most of them of course failed, but here's the good thing, that we've actually got the layout for exactly this version. So this is what I wanted to just double check. And when we get to the specification, this is from the instruction book, and the circuit is from the instruction book. We can see that it is sensitivity is 1 microvolt for 10 dB cyanide. We're already well beyond that, so that's good to know. So we go to this. There's a dry joint somewhere on the transmitter. I will need to find that, but I'm sure we will be able to. This one, which I wasn't sure of, is the amount of 10.24 that goes to the IF. So it takes some of the 10.24 which is going to the synthesizer, and it takes it for the intermediate frequency. That's why I was trying to measure it at pin 1, but without success. So just to see whether we can improve, take that to 12, and just see there we go, we've got a little tiny bit more. So now we can write down our results. 0.45 for 10 dB, 0.37. They're pretty bleed overish, as I say. And for 20 we've got 1.6. Come back to squelch, it's lousy and it's not adjustable. The control needs spraying. So that's done that. So now we're avoiding the VCO because that's right. We're going to have to poke the thing down these, which I don't like these being sealed. Very carefully. Let's make sure we've got adjustment. Yep. I'm going to transmit. Let's put the main meter up. So we want this in the centre of the peak. At the moment, from cold, it's doing 4.5 watts. Smithing away from 5 there. turn down with that. Oh, that's too tight. So, in conclusion, there's a dry joint on the transmitter which I haven't got to the bottom of. I'll get Mr. Chippie to do that, but I think we'll do the on-the-air test. There'll probably be some noise from that, but that's fine. So it's 2.2 to 2.5. It's 4 watts there. Let's have a look at my walkie-talkie on. Channel 40, 3.5 watts. This is to do with this dry joint. 4 watts. Low power we set to 400 milliwatts, just check. And our current consumption on full power is now 1.06 amps. It's a squelch, isn't it, which we're left with. So set squelch. It's 0.3. So that's going through the IF's fixed that. And let's see where it is for maximum. I said a bit wishy-washy, the squelch on these. It's 1 microvolt. You know, that's weak as dishwater, isn't it? Anything outside of a rural environment and it'll be all over the place, opening up. Right, so we've got 4 displayed on there. We've got 100 microvolts on there. And we'll see whether the internal speaker actually works. So we started off looking at that Signal 1001. One day there'll be much more time, hopefully. But at least I've got the circuits out. I mean, that set's already been scrapped, so we're not holding that much hope, but right. So I'm not going to screw the lids on. I want to go over this with isopropyl alcohol, but I also want to get the on-the-air test done if we can. So there's going to be a bit of dry jointness. It might crackle on transmitters, those dry joints show up. But I haven't found them myself. Let's put it on the aerial. Turn the test gear off. I think these are one of these sets that are prone to humming, because certainly the York 867 and the Murphy, which are kind of the same thing with a different synthesizer. On a Roger. Well, we've got squelch action out here in the middle of nowhere, but I don't think anybody else would. So there you have it, the JWR M2 from 1981. One of the sets that is a bit of a bleed over box, but have really nice transmitted audio. So we'll see how it goes on the air test. Thanks for watching.